In the case of repeated multiplication with the same number, we can rewrite the expression using exponents. For example, 4 times 4 times 4. We can write that using an exponent. This same number that's referenced in the definition is 4, and how many times do we see 4? It's a factor 3 times, so the exponent will be 3, so 4 to the third power. Parts of an exponential expression include x here as the base and the n as the, if you said exponent, you're correct. We can read this as x to the nth power. For the next few examples, the directions say to write each expression using exponents, then evaluate if possible. So we see 11 times 11. The base is going to be that same number as a factor. So what factor is the same each time? 11, that's your base. The exponent is how many times that factor appears. How many times do we see 11 as a factor? Twice. The exponent is 2. Can we evaluate 11 squared? 11 squared is the same as, again, 11 times 11, which gives us 121. For the next one, we have 2 times 2 times 2 times 2 times 2 times 2 times 2. How many 2's do we see? There are 7. So 2 to the 7th power. When we multiply 2 to the 7th power, again, it's 2 times 2 and then times 2 again. You can chunk those, and you can do 2 times 2 giving you 4, and then 2 times 2 giving you 4 there, and then 2 times 2 giving you 4 there. So it's like 4 times 4 times 4 and then times 2. And when we multiply all that out, we get 128. The next one says negative 5 times negative 5 times negative 5 times negative 5 times negative 5. Here, the base is a negative number. It's in parentheses so that we understand that we're going to have negative 5 as the base. So negative 5, how many times is it a factor? 1, 2, 3, 4. So negative 5 to the 4th power. When we multiply negative 5 to the 4th power, anytime you have an even exponent with a negative, the answer turns out to be a positive. Why? Because you have a negative times a negative here, that's going to be a positive. And then you have another group of negative and negative making positive. So in the end, it's a positive times a positive. And that gives us 625. The next one, we have a fractional base, or a fraction as a base. So how many times do we see this fraction appear as a factor? We see 1/4 appear as a factor 3 times, so it's 1/4 to the 3rd power. Here again, you multiply fractions straight across, so numerator times numerator times numerator gives us 1, and denominator is 4 times 4, which is 16 times another 4 gives us 64, so 1 over 64. For the next expression, we have 7 times 7 times 4 times 4 times 4. Here we can write this out as 7 raised to the 2nd power times 4 raised to the 3rd power. Why? We see 7 as a factor twice, and we see 4 as a factor 3 times. Remember, we're still multiplying. We just wanted to show it in exponential form, or as an exponential expression. So as we continue here, we can multiply 7 times 7, which gives us 49. And then we do 4 times 4, which is 16 times another 4 is 63. So 49 times 64 gives us what? 3,136. For the next expression, we have 8 times negative 2 times negative 2 times 8 times negative 2 times 8 times 8. Here, we can use the commutative property of multiplication to move all of our 8's together and all of our negative 2's together. Or we can simply do that as we're writing our exponential expression. By taking a look at 8 first, how many times do we see 8 as a factor? 4. So 8 to the 4th power times, how many times do we see negative 2 as a factor? 3 times. So we have 8 to the 4th power times negative 2 to the 3rd power. Now we have negative 2 times negative 2, which is positive 4. But when you multiply positive 4 times that last negative 2, that gives us negative 8. So here we know our answer is going to end up being negative. When you multiply these numbers out, you end up with negative 32,768. For the next one, same thing. We can use the commutative property, or you can simply just group them as you write them in exponential form here. We have, if we want to start off with a fraction, we would have 2/3 raised to the second power times 9 raised to the second power. So that's going to mean, for that fraction, 2 times 2, which is 4 in your numerator, and 3 times 3 is 9. So it's going to be 4/9 times 9 times 9, which is 81. When we do that, we're going to end up dividing and simplifying in the end to give us 36. Here we have some algebraic expressions, if you remember that term. And we say algebraic because, remember, algebraic has variables. So here we have lots of a's being multiplied. How many a's do we have? 2, 4, 6, 8, 9. So that's going to be a to the 9th power. Now we have xy as a factor 1, 2, 3, 4, 5 times. So we would write xy to the 5th power. Alright, there's no value for a to the 9th power. By the way, that's as simple as it could be. And for xy to the 5th, that's as simple as it can be. We can only evaluate it and give a value, a numerical value, if we substitute in a value. So we have to evaluate it first to give a value. So I would have to say when a is equal to 1. And then we could say the answer was 1. Or for the next one, for xy, we'd say x is 1, y is 2. So that'd be 2 to the 5th power, that kind of thing. Alright, let's continue on. 2, we have r times s times s times s times t times s times t times t times s times r. So if we begin with r, how many times do you see r as a factor? I see r twice, so r to the 2nd power. And then next we can go with s. I see s 5 times, so times s to the 5th. And then times, what do we have next? T. How many times do we see t as a factor? 3 times. Can we put a value there? No, because we need some numbers to evaluate it. Alright, the next one. We have k times 9 times k times k times 9 times k times k times k times 9. Alright, 9 is a factor 3 times, so 9 to the 3rd power. Times k, we see k as a factor 6 times, so it's going to be times k to the 6th power. We can evaluate this, and when we evaluate this, we can do 9 times 9, which is 81, times another 9 gives us 729. K to the 6th power. That's as simple as that can go. If we want just a numerical value, we have to evaluate this when k is equal to a given value. Alright, the next one is negative 7 times m times m times n times m times negative 7 times n. If we begin with negative 7, we see negative 7 as a factor twice, so negative 7 squared. And then we see m as a factor 3 times, so times m to the 3rd power. And then we see n twice, so times n to the 2nd power. Alright, we can evaluate negative 7 times negative 7, which is going to give us 49. Remember, negative times a negative is a positive. So we're going to end up with 49 m to the 3rd power, n to the 2nd power. And if we remember, or as we move forward, when we write things in in standard form, we write them according to the degree, so the exponent. So the 3 would come first, and then n to the 2nd power would come second. Just looking forward. All right, as we look at the next one, we have p minus 2 times p minus 2 times p minus 2. How many times do we see this binomial or this expression being multiplied? 3 times. So we can write p minus 2, or the difference of p and 2, raised to the 3rd power. Can we put a value there? No, because we need some numbers to fully evaluate. All right, and as we move forward, a plus b times 6 times 6 times a plus b times 6. I see 6 as a factor 3 times, so 6 to the 3rd power, times a plus b is a factor twice, So we can simplify that. 6 times 6 times 6 is 216. And then we keep the a plus b squared, or the sum of a and b squared.